All right, let's talk about generative AI. You've seen it everywhere, right? It's the big buzzword. But what's really going on under the hood? Today, we're going to cut through all that noise and break down exactly how this incredible technology works, piece by simple piece. Let's dive in. You know, it really all boils down to this one question that honestly sounds like something out of science fiction. How can a machine, a bunch of code and circuits, actually create something original? A poem, a picture, a song, something that didn't exist before? That's the big puzzle we're going to solve together.
And we've got a roadmap to get us there. We'll kick things off with a simple definition, then get into the weeds of how AI understands language. After that, we'll meet the different types of AI models, see what they're actually doing out in the real world, and then, my favorite part, we'll see how an AI is actually born.
Okay, so first things first. Before we get into the nitty-gritty, let's just strip away all the technical jargon and figure out what we are even talking about here.
At its heart, generative AI is, well, exactly what it sounds like. It generates stuff. See, other AIs might be really good at classifying things or spotting patterns, but these models are built to be creators. They make brand new content that has never existed before. That's the key. It's about producing, not just analyzing.
So, for an AI to create something with words, it first has to get a grip on our language. But it doesn't read a sentence the way you and I do. It needs to chop our language down into a format that a computer can actually understand. So let's look at those building blocks.
Everything, and I mean everything, starts with something called a token. When you feed a sentence into an AI, it doesn't see the whole thing. It shatters it into these tiny little pieces, the tokens. A token might be a whole word, like computer, or just a part of one, like the ing in running, or even just a question mark.
The best way to think about this is like Lego. If language is some big, complicated castle, tokens are the individual little bricks. The AI doesn't start off knowing what a castle is. It just learns through massive trial and error how every single brick can snap together with every other brick to eventually build one.
Okay, but these Lego bricks, these tokens, are still just words. To a computer, castle is meaningless. So here comes the next bit of magic, embedding. This is the process that turns each token into a long list of numbers. It's called a vector. And this string of numbers mathematically captures what that token means and how it relates to everything else.
So think of it like a giant GPS for meaning. In this huge, invisible map of language, the coordinates for king are going to be really, really close to the coordinates for queen, but they're going to be miles and miles away from the coordinates for banana. This is how the AI actually navigates the relationships between ideas. It's all just math.
So now that we know all that, how do we actually talk to the AI? Well, that's where prompt engineering comes in. It's really the art of crafting your questions and instructions in just the right way to get the best possible result. A great prompt is like giving a brilliant artist a really clear and inspiring brief. It just guides them to create exactly what you're imagining.
Okay, so we've got how the AI understands language, but what is the thing doing the understanding? It's time to meet the AI models themselves. These are the brains of the entire operation. You can basically put them into two main camps. On one side, you've got your foundation models. Think of these as a university graduate with a huge general knowledge about pretty much everything, because they've been trained on a massive slice of the internet. Then, on the other side, you have fine-tuned models. This is like that same graduate deciding to go to med school. They take all that general knowledge and then train super intensely on a specific, smaller set of data to become a real expert in one specific thing, like medical diagnosis. And the variety is just incredible. You've got transformer-based LLMs. Those are the powerhouses behind things like ChatGPT. You've got multimodal models, which are wild because they can understand text and images all at once. And then you have diffusion models, which are basically the artists of the AI world, creating those mind-blowing images you see online.
This is all really cool in theory, right? But so what? Why does any of this matter to you and me? Let's take a look at what this technology can actually do out in the world right now.
The applications are just exploding everywhere. We're way past just making cool art. This tech is summarizing 1,000-page reports in seconds, it's translating languages on the fly, it's writing computer code, it's powering chatbots that feel incredibly real, revolutionizing customer service, and completely changing how we search for information and get recommendations online. It's a true game changer.
So where do these powerful tools even come from? I mean, they don't just spring into existence. Building a foundation model is this massive, deliberate, and incredibly complicated undertaking.
So let's pull back the curtain and actually see how an AI is born.
It's basically a 6-step journey. First, you have to collect and clean a mind-boggling amount of data. Then you choose the right architecture for the model and start what's called pre-training. This is its general university education. After that, it might be fine-tuned for a specific job. It's med school. And before it ever sees the light of day, it goes through brutal testing for performance, safety, and bias. And only then is it deployed, where it keeps on learning from how people use it.
And that brings us right back to the beginning. We started this whole journey with one single token, a tiny little Lego brick of language. And we've seen how, through this intense cycle of learning, testing, and refining, those simple little bricks get assembled into one of the most powerful tools our world has ever seen.
So we get the how now. The technology is here, and it is moving at a speed that is hard to even comprehend. And that leaves us with maybe the most important question of all. Now that we know how these incredible tools are built, what should we ask them to build for us, for our future? That's the question we all get to answer next.